Modern frontier models exceed 1 trillion parameters. To run these architectures, a deep learning job requires massive GPU clusters, calculating relationships between billions of weights. Yet despite this processing power, these models are stateless. Their memory exists entirely within a volatile context window, much like computer RAM. The moment a session ends, the model's memory effectively resets, forgetting every action it just performed. This creates an immediate failure in the enterprise. If you ask a stateless model to prepare a brief for a vital client meeting scheduled for tomorrow morning, it can only provide a generic template. It has no access to the specific support tickets, the recent deal history, or the internal pricing rules that exist within your private company databases. Without the ability to retrieve and understand these real-world constraints, raw model intelligence is an ineffective tool for specialized business operations. Solving this requires context engineering, the architectural discipline of securely connecting an AI model to external, proprietary data sources in real time. This discipline focuses on 3 pillars: the precision of data delivery, the latency of real-time access, and the enforcement of strict governance permissions to ensure users only see data they are authorized to access. Model reasoning is no longer the primary bottleneck in the industry. The current frontier is engineering the systems that deliver the right context to those models at the right time. The foundational technology for this is Retrieval-Augmented Generation, or RAG. It allows a model to look up information from external documents before it generates a response. During the ingestion phase, enterprise documents are sliced into smaller data chunks. This prevents important details from being diluted and ensures the model isn't overwhelmed by irrelevant information. These chunks are converted into vector embeddings, high-dimensional numerical representations of their meaning. These are stored in a vector database, where the system can mathematically map how every concept relates to every other concept. When a user asks a question, the system performs a similarity search. It identifies the vectors in the database that are most relevant to the query and retrieves only those specific chunks of information. As shown in this RAG pipeline, the retrieved results are passed into a context injection block. This combines your proprietary data with the user's prompt, creating a single grounded input for the Anven inference engine. This architecture forces the model to cross-reference the internal knowledge base before answering. If a specific data point does not exist in the database, the engine is programmed to report that absence rather than fabricate an answer. While standard vector search works for simple lookups, it struggles with highly relational data, where hierarchies and connected entities are more important than keyword similarity. GraphRAG addresses this by mapping out structured relationships between entities. Instead of just finding similar text, the system can reason through which specific documents relate to which specific clients or projects. However, enterprise intelligence is almost never just text only. Critical information is often locked inside network diagrams, screenshots, and scanned PDFs. Late fusion multimodal processing allows the engine to process visual image tokens and text tokens simultaneously. This allows a model to reason over a network diagram while reading the corresponding policy paragraph. To navigate a company's raw data landscape, an enterprise context engine must be able to reason across both relational structures and visual data types. Treecapital Technologies operationalizes these architectures through the Anven AI ecosystem. It is a specialized, RAG-native reasoning engine built for production-ready deployment. In this LangChain framework, the Anven model acts as the central hub. It routes reasoning logic through integrated memory and retrieval modules to secure required context. Using a chain architecture, the RAG module's output directly inputs to the agentic layer for autonomous execution. Connecting an LLM to an orchestration hub allows the system to autonomously determine the optimal toolchain for task execution, from summarizing SQL databases to interfacing with search APIs. Context engineering allows highly regulated industries to use generative AI with precision. In finance, teams use these agents to analyze transaction pipelines in real time, cross-referencing customer data to flag fraud anomalies. Legal firms utilize these systems to search private case law databases. The agents draft contracts and identify relevant precedents based strictly on proprietary case history that never leaves the internal network. Healthcare providers use late fusion models to synthesize sensitive patient records with medical imagery. This provides clinicians with an integrated view of data without exposing it to public models. In these high-stakes environments, The ability to ground responses in verified proprietary data is a strict operational requirement. The final requirement for context engineering is runtime governance. Every request must be audited to ensure compliance with organizational policies and privacy laws. Attempting to provide this level of proprietary context to public AI APIs creates a massive data exfiltration risk for the enterprise. This is the move to sovereign infrastructure. Deploying Anven within private clouds or air-gapped environments achieves total data autonomy. This architecture ensures zero data exfiltration while meeting strict mandates of HIPAA and GDPR, as processing happens inside the firewall. Deploying a privately governed intelligence engine allows an enterprise to operate at full capability without losing ownership of its proprietary data.